In the next few lessons, we're going to continue our discussion of trigonometry and look at the graphs of trig functions. As we'll see from their graphs, trig functions are examples of repeating functions, which are also called periodic functions. So before we talk about the graphs of trig functions in particular, let's introduce some new terminology that we use for repeating functions in general. So first of all, a periodic function is a function that has y values which repeat at regular intervals. And the word period means the length of a single cycle, how long it takes the graph to repeat. To look at a few examples, this first wave here is an example of a periodic function, because as we go from left to right, we see that the y values repeat at regular intervals. So this is a periodic function. This middle one, although looking more complicated, is also an example of a periodic function, because if we, for example, start here and go to here, we see that this picture repeats again at regular intervals. The y values are repeating, so this is a periodic function. This one looks similar to start with, but as we can see, it's getting wider as we go to the right. So the y values are not actually repeating at regular intervals. Although there is some regularity here, we would not call this one a periodic function. Next, let's look at some of the terminology that we use with periodic functions. We've already introduced the term period, which means the length of a single cycle. Looking at this example, we can see that if we go from this peak here, which is at about x is equal to 6, to this peak here, which is around x is equal to 12, then the function's repeating every 6 units. It does so again here, and does so again if we go backwards. So the period is about 6. It's not exactly 6, but it's close. The next term is axis, and the axis is the horizontal line around which the function is oscillating. It's the horizontal line that cuts through the middle of the function. And we can see here that on this function, the line y is equal to -3 cuts through the middle of the function vertically. Sometimes you'll see a formula for finding the axis. And that's that the axis is the average of the maximum and minimum values of the function. So if we take the max and the min and divide by 2, here the maximum value the function achieves is -2, and the minimum value that it achieves is -4. And we divide that by 2, in other words, finding the average, we get -6 over 2, which is equal to -3. So y is equal to -3 is the axis. And be careful, because the axis is a line, it needs an equation. Because it's a horizontal line, it gets an equation of the form y is equal to something. The next term we need to know is amplitude. Amplitude is the distance from the axis to either the peak or the trough. And because the axis cuts through the function in half vertically, that distance from the axis to the peak or the axis to the trough will always be the same. As we can see here, the distance from the axis to the trough is 1, and looking here, we can see the distance from the axis to the peak is 1. So the amplitude is simply 1. And there's also a formula for finding the amplitude. It doesn't need an equation because it's just a number. So the amplitude is equal to the maximum minus the minimum divided by 2. In our example, the maximum, as we said, was -2. The minimum was -4, so now we're subtracting those two. And being careful with our signs, we get -2 plus 4, which is going to be 2 over 2, is equal to 1. And as we found here by looking on the diagram, the amplitude was equal to 1. So these are formulas that you'll sometimes see. It's often easier just to work directly from the graph. Let's look at another example. Here's a more complicated function, but again, we can work out everything we need from the graph. The period is the length of a single cycle. If we look here and we look here, this is about x is equal to 4, maybe a bit less, and this is about x is equal to 10. So again, the period is around 6. This time, the axis is up here, and we could use the formula that we just talked about to find it, but we can also see that if we draw this line, it's equally spaced from the troughs and the peaks. So that's the axis, and looking across here, that's the line y is equal to 4. And again, the amplitude is the distance from the axis to the peak or the trough, and looking here, we can see that that's equal to 2. Careful that the amplitude is not 4, it's not the whole distance, it's the distance from the axis to either the peak or the trough, which will always be the same. So that's an introduction to periodic functions.